This is section 4.7 part 3, where we are going to solve by completing the square. So completing the square is going to use the process of b over 2 squared that we just learned in the previous part of section 4.7. So in order to complete the square, you can see we want to set the equation to ax squared plus bx equals the opposite of c. So if you have a number over here, you want to bring that number, that constant, over to the other side. So ax squared plus bx is alone. Then what we're going to do is we're going to add b over 2 squared to both sides. This b over 2 squared is going to become our new c, which is going to make a perfect square trinomial here. But we have to add it to both sides, because remember, what you do to one side of an equation, you have to do to the other to keep it balanced. All right, so you can't just add b over 2 squared to one side of the equation. So we're going to look at two different forms. We're going to look at ax squared plus bx plus c equals 0 when a is 1. Alright, because you're going to complete the square differently if a is 1 or if a is not 1. So here, this value of a is going to be 1. Alright, we're not going to really see a number in front of x squared, alright, because it's implied that it's 1. So in the first problem, we've got x squared minus 16x plus 8 equals 0. So I've got my ax squared plus bx, and then I've got my plus c. I want to get the ax squared plus bx alone. So I want to isolate this piece right here that I've highlighted. I want to isolate that. So as the first step in the directions up here, it says bring this constant to the other side. So I'm going to subtract 8 from both sides. These 8's cancel, and I have x squared minus 16x equals negative 8. Notice I've left a little space here because what I want to do next is I'm going to add b over 2 squared to both sides, because b over 2 squared, this is going to be our new c. Alright, b over 2 squared is going to be our new c. So what is our b? Our b is negative 16. So I'm going to add negative 16 over 2 squared to both sides. And now I want to simplify this. So I've got x squared minus 16x plus, we've got negative 16 divided by 2 is negative 8 squared. And then I've got negative 8 plus negative 16 divided by 2 is going to be negative 8 squared. So what is negative 8 squared? Negative 8 squared is positive 64. Alright, negative 8 squared is positive 64. So I'm going to show you something here. I'm going to just write in positive 64. In both of these cases, you don't have to do that yet. Alright, positive 64, positive 64. This is a perfect square trinomial, which is going to essentially break down into a minus b squared. Alright, where I take the square root of x squared to get my a. So the square root of x squared is x. Take the square root of 64 to get my b. The square root of 64 is what? 8. And we see it's going to be minus. And our answer is squared. And then I want to add these two together. So negative 8 plus 64 is going to give me positive 56. Alright, so next, what do we do? Alright, we would then end up taking the square root of both sides to get rid of this square. Alright, so, but I'm going to go backwards in time here. And what you guys have down on your paper, because you haven't erased that yet, because I ask you not to, is you have negative 8 squared here. And you have negative 8 squared over here as well. Take a look at what happened. We've got negative 8 here and negative 8 here. Because you created a perfect square trinomial, a nice little shortcut, and it will reduce your time. You won't have to factor, is whatever number you have, whatever b over 2 is, you simplify and you get a number in parentheses. Before you square, this number will always be the number that's going to go in here. That will always be the case. Alright, so you don't necessarily have to square this and then figure out what this number has to be. If you can remember that this number simply plops in right here, you'll be good to go. Alright, and then you'd want to always simplify the right hand side, and you'll end up getting 56. So the next step is to isolate this whole quantity by getting rid of the square. So I'm going to take the square root of both sides and simply get x minus 8 equals plus or minus the square root of 56. 56 is not a perfect square. Alright, the last thing, I think it's the last thing, is to add 8 to both sides. So I'm going to add 8, these 8's cancel, and I get x equals 8 plus or minus the square root of 56. Before you can be confident you're done, you have to check to see if this is completely simplified. So I'm going to go ahead and use my factor tree real quick and say, okay, I've got 56. What numbers go into 56? Well, 4 goes into 56 14 times. And 4 can be broken down into 2 and 2. So remember, a pair of numbers will get written once, and the lonely number up here gets written only once. And we know square root of 14 because 14 can't get broken down anymore. It can get broken down into 2 and 7. Alright, but those numbers can't get broken down any further. Alright, so we don't have another pair here. So you essentially do 2 times 7 to get back to 14, and this is our final answer. X equals 8 plus or minus 2 root 14. We're going to complete the square again. It's a very similar process, only we have now ax squared plus bx plus c equals 0 when a is not equal to 1. Alright, so you really have to pay attention to what your leading coefficient is. You don't want your leading coefficient to be a number other than 1. If it is, you have one extra step. Alright, you cannot complete the square when this number is not 1. So we need to make this number 1. So what you do is you divide both sides of the equation by whatever that leading coefficient is. So what's our leading coefficient? 2. So our first step is to get our leading coefficient to be 1. So I'm going to divide both sides by 2 first. So 2x squared divided by 2 gives me x squared. 16x divided by 2 gives me 8x. And 8 divided by 2 gives me 4. And 0 divided by 2 is still 0. So now I have a leading coefficient of 1. Alright, so we'll make a little note here for your notes. You can't complete the square when your leading coefficient, or a, is not 1. So to get a to be 1, simply divide both sides of the equation by a. And the reason I've taken the time to write this down is a lot of students forget to divide by that a value, that leading coefficient. They'll try and complete the square without dividing first. So it's really important that you remember to divide by that leading coefficient first in order to complete the square. Now the process is the exact same as above. Once we've got a leading coefficient of 1, we want to isolate our ax squared plus bx. Alright, so we can add our b over 2 squared to both sides. So I'm going to bring over the 4. And we've got x squared plus 8x equals negative 4. Remember, we're going to add b over 2 squared, which is 8 over 2 squared, to both sides to keep our equation balanced. What you do to one side of the equation, you have to do to the other. So I've got x squared plus 8x plus 8 divided by 2 is 4 squared. And 4 squared is 16. So I'm just going to, instead of keeping 4 squared, I just squared it. So 4 squared is 16. Wrote that here. And remember what I said in the previous section, right up above, is that whatever number you have here, since this is a positive 4, you're definitely going to have a positive there. So you're going to have a plus 4. This number gets transferred down, always. And I'm just going to have x plus 4 squared equals negative 4 plus 16 is a positive 12. Take the square root of both sides, and I get x plus 4 equals plus or minus the square root of 12. Subtract 4 from both sides, and we see x equals negative 4 plus or minus the square root of 12. And then you want to ask yourself, all right, can 12 be simplified? All right, so we're going to go ahead and make our factor tree. Say 1 and 12, well, that won't help us. 2 and 6 could, but I'm going to go with 3 and 4. 4 gets broken down into two sets of 2. Whatever pair we have gets written once. And then our lonely guy is still underneath the square root, the radical. And there's your answer. X equals negative 4 plus or minus 2 root 3.